Hi everyone, this is Professor Oaks, and in this video we are going to discuss quadratic functions and models. So let's first talk about polynomial functions of degree n. So a polynomial function is a function that is defined by a polynomial expression. So a polynomial function of degree n is a function of this form here. P of x is a sub n x to the n plus a sub n minus 1 x to the n minus 1 and so forth, where the coefficient of the x to the n term cannot be equal to 0, because if it was, then this would only be x to the n minus 1 power here. Alright, so what is the degree of p of x equals 5x to the 7th plus 6x to the 6th plus 4x to the 5th plus 8x to the 4th plus 7x to the 3rd plus 6x squared plus 5x plus 2. So you can see here that this will be a 7x to the 7 plus a 6x to the 6 plus a 5x to the 5th plus a 4x to the 4th plus a 3x to the 3rd plus a 2x squared plus a 1x plus a 0. So you see that the highest power is 7, and that is the degree. So this is 7, the degree, and it's the degree, which is 7. So specifically, a quadratic function is of the form f of x is ax squared plus bx plus c, or if we write it in the notation of a general polynomial function, it's a 2x squared plus a 1x plus a 0. Alright, so this is just another way to write the quadratic function, is just using a, b, c instead of a2, a1, and a0. So let's talk specifically about the graph of a quadratic function now. So before we graphed the quadratic function by plotting points, then we graphed these by transformations, and now we're going to look at graphing quadratic functions more accurately. Okay, so here are some new words for you, maybe. The axis of symmetry of a quadratic function is the line that goes straight down the middle of the parabola or the quadratic function. And if the a here is greater than 0, then this opens upward, and the vertex is what is called the lowest point here. And then if the a is less than 0, then the parabola or the quadratic function opens down, and the axis of symmetry again just goes straight down the middle here, and the vertex is the highest point right here. Alright, so given this information, let's indicate whether the graph of each of the following quadratic functions opens up or down. So this f of x is in the form ax squared plus bx plus c, and a equals 3, which is greater than 0, so this opens up. Alright, here is g of x equals negative 6x squared plus 1, so this is in the form of ax squared plus 0x plus c. Alright, so just remember the a cannot be 0, but the b could be 0. And a is negative 6, which is less than 0, so this opens down. And then we have, let's see, what do we have here? We have h of x is 1/2 x squared plus 2/3 x. So we have a x squared plus b x plus 0. Again, it's okay for c to be 0, but here we have a is a half, which is greater than 0, so this opens up. So when a quadratic function is rewritten in the special algebraic form, f of x equals a times x minus h squared plus k, we can use transformation techniques to graph it by using the standard graph of y equals x squared. And the graph of any quadratic function then again is called a parabola. So if in this form here the a is greater than 1, then it's a vertical stretch. If the a is actually less than 1 here, it's a compression. And then remember, of course, if the a is negative, then we will do a reflection across the x-axis. The h represents the horizontal shift left or right here, so it's left if h is less than 0 and right if h is greater than 0. And the k represents the vertical shift, it's down if k is less than 0 or up if k is greater than 0. So let's match each of these quadratic functions with its graph. So we see here we have several options here, so let's just look at these fairly closely here. So this one is x squared, and this one is x squared, negative x squared, negative x squared. So we know which ones open up, and we know which ones open down. And then we also know that this is a plus 4, so this is the y-intercept of 4, and this is minus 8, a y-intercept of 8. So let's look at these very carefully, and I see that the one that opens up with the y-intercept of 4 is this one. That means the other one that opens up has to be this one here. And this one opens down with a y-intercept of negative 8 here. Oh, did I say 8? It's clearly negative 8. I circled that and then just said 8. But there we see it's right here. So that must be C. And that means that this is the other one. So there we go. A, D, C, B. Easy enough. All right. By the way, there's other things that you could do here that we've discussed before. Like this one, f of x, you could factor into x minus 2, and then you can see that it had zeros at x equals 0 and x equals 2, so you could look at the zeros. This one I could not factor because I can't factor the sum of two perfect squares into something involving the real numbers. And then there's sort of the same thing here if you factor out the negative and then have x squared plus 8. And here, what do you have? You have a negative x times x plus 8. And I see that for D, the zeros were at x equals negative 8 and x equals 0. Now, by the way, if I look at the graph, I see that B and C did not have any real zeros anyway because neither of them actually had a graph that intersected with the x-axis. So keep that in mind as well. In this example, let's use the graph of f of x equals x squared along with transformations to graph each of the following functions, and then find the vertex and x is a symmetry of the parabola, and also determine the domain and range. So let's start with f of x equals x squared, which has points at 0, 0, at 1, 1, and at negative 1, 1. All right. So now this is f of x equals x squared. Now let's graph f of x equals x minus 2 squared. So this is a shift 2 units to the right. All right, so here we go. So the negative 1, 1 becomes, when we shift 2 units to the right, 1, 1. The 0, 0 becomes 2, 0. And the 1, 1 becomes 3, 1. So this is what this looks like. Now let's graph f of x equals 2 times x minus 2 squared. So this is a vertical stretch of 2. So that means multiply all of the y values by 2. So this 1, 1 becomes 1, 2. The 2, 0 remains 2, 0. And the 3, 1 becomes 3, 2. And you can see that this parabola opens more narrow than this one did. And now we have f of x is 2 times x minus 2 squared minus 2. And this minus 2 means a shift 2 units down. So the 1, 2 becomes 2, 0. The 2, 0, 1, 1, 2 becomes 1, 0. There we go. I have it right now. All right. So now the 2, 0 becomes, if I shift down 2, 2, negative 2. And the 1, 1, 2 again became 1, 0. The 2, 0 became 2, negative 2. And the 3, 1 will become 3, 0. So here is the same parabola. Shift it down 2 units. All right. And actually, here, just to avoid any confusion, I'll just remove that tick mark. Now, the minimum here is the vertex, so that's at 2, negative 2. The axis of symmetry is the line right down the center of the parabola, so that is x equals 2. The domain is negative infinity to infinity, since this is a polynomial. And the range is the lowest y value, which is negative 2, all the way up to infinity. All right, so hopefully that makes sense that this is all coming from the graph. All right, so now let's try another one. We have f of x is equal to negative x plus 1 squared plus 3. So let's start with f of x is equal to x squared. So again, we have points at 0, 0, 1, 1, negative 1, 1. And let's graph then f of x equals x plus 1 squared. This is a shift 1 unit to the left. All right, so left 1 unit. So the 1, 1 becomes, well, the 1, 1 becomes to the left 1, all right, 0, 1. The 0, 0 becomes negative 1, 0. And the negative 1, 1 becomes negative 2, 1. And here we go. This is what this looks like. Now, let's multiply by the negative 3 to do the vertical stretch of 3 and a reflection. All right, so we're going to multiply all the y values by negative 3. So 1, let's see, if y is 1, that means y is now going to be negative 3. So we have a point at negative 2, negative 3. And if y is 0, it stays 0. So we have a point at negative 1, 0. And if y is 1, it becomes negative 3. So we have a point at 0, negative 3. So the graph will look like this, reflected and stretched a little bit. And then we have f of x is negative 3, x plus 1 squared plus 3. This plus 3 means to shift 3 units up. So the negative 2, negative 3 becomes negative 2, 0. The negative 1, 0 becomes negative 1, 3. And the 0, negative 3 becomes 0, 0. And this is what the parabola looks like. So the vertex is the maximum, which is negative 1, 3. The axis of symmetry is negative infinity to infinity, since this is a polynomial. Sorry, the domain. I thought I had, okay, axis of symmetry is x equals negative 1. Whoop, I'll just rewrite this. I read axis of symmetry and then looked at the line for domain. So luckily, I noticed it before I got too far, right? And the range is negative infinity up to the largest y value, which is 3. So negative infinity to 3. All right. Hopefully you enjoyed this example. And what a time to be alive. Now, you can see some more general steps for graphing a quadratic function. One of these is to complete the square so that you can write the function in the standard or the special form that we just talked about, and then graph the functions using transformations just like we have. Or you can do option 2, which is all of these 6 steps here. Either of these is okay. So let's graph the function f of x is 2x squared minus 3x minus 2 using both of the 2 options that was just mentioned here. All right, so here you see that this is not in the f of x equals a times x minus h squared plus k form. So we need to use completing the square to write the quadratic in that format. All right, so f of x is 2x squared minus 3x minus 2. Another way to write that is 2 times 2, or equals 2 times x squared minus 3x minus 2. And I will actually go ahead and divide the coefficient of the x squared out. So I have y over 2 is x squared minus 3 over 2x, and then minus 1. Now that the coefficient of x squared is 1, I can add a half of b, right? A half of b squared, and subtract a half of b squared, All right, so I'm just doing this to figure out what would complete the square. Well, this b right here was negative 3 halves. So I have y over 2 is x squared minus 3 over 2 plus a half times negative 3 over 2 squared minus a half times negative 3 over 2 squared minus 1. And then I have y over 2 is equal to x squared minus, here, let's make that a little bit nicer of a negative sign here for you. So minus 3 over 2, and this is plus a negative 3 over 4 squared minus a negative 3 over 4 squared minus 1. So y over 2 is x squared minus 3 over 2. I'll square this out, so that plus 9 over 16 minus 9 over 16 minus 1. And now I can factor this into, all right, let's see. It will be, I'll write it over here, y over 2 is x minus 3 over 4 times x minus 3 over 4. And then you can of course check this if you would like by multiplying back, but it's actually just this number. All right, x minus 3/4, x minus 3/4. And then let's find a common denominator for the 9 over 16 and the 1 here. So this will be 16, so minus 9 over 16 minus 16 over 16 is minus 25 over 16. So we have y over 2 is x minus 3 over 4 squared minus 25 over 16. Then I will multiply by 2, every term by 2 to get y is 2 times x minus 3 over 4 squared minus 25 over 8. So the a is 2, the h is 3 over 4, and the k is negative 25 over 8. So the vertex of the function is always hk, so that's 3 over 4, negative 25 over 8. And now I will find the x and y intercepts of the function. So the x-intercept, I can find that by letting y be equal to 0. And so then, let's see, so if I have 0 is equal to 2 times x minus 3 over 4 squared minus 25 over 8. Let's add the 25 over 8. So 25 over 8 is 2 times x minus 3 over 4 squared. Then I will divide by 2. So 25 over 16 is x minus 3 over 4 squared. I'll take the square root. So plus or minus 5 over 4, so plus or minus 5 over 4 is equal to x minus 3/4. Then add the 3/4, so 3/4 plus or minus 5/4 is equal to x, and 3/4 plus 5/4 is 8/4, which is 2, and 3/4 minus 5/4 is negative 2/4, which is negative 1/2. So these x-intercepts are at 2, 0, and at negative 1/2, 0. All right, so for the y-intercept, you can let x equal 0. So f of 0, or you could use the form that we completed the square on, it doesn't matter. 2 times 0 minus 3/4 squared minus 25 over 8. So it's 2 times negative 3/4 squared minus 25 over 8. That's 2 times 9 over 16 minus 25 over 8. 18 over 16 minus 25, 18 over 16 minus 25 over 8. Yep. So that would be 9 over 8 minus 25 over 8. So that will be, what will that be? That will be negative 16 over 8, which is negative 2. And by the way, in this case, it would have been easier just to look at the function in its original form, the general form of it, and see that the y-intercept was negative 2. So this actually made it take a little bit longer. But in either case, we still have a point at 0, negative 2. All right, so let's go ahead and graph the function in stages using transformations now. So you would start out with, remember, f of x is x squared. Then we have f of x is going to be x minus 3/4 squared. Then we have f of x. So the next one we would have is 2 times x minus 3/4 squared. And then, oh boy, f of x or y, it doesn't matter, but I'll just keep the f of x for all of these now. So f of x is 2 times, excuse me, x minus 3/4 squared and minus 25 over 8. But remember, this had a vertex at 3 over 4, negative 25 over 8, and intercepts at 2, 0, negative a half 0, and 0, negative 2. So even without doing all the transformations, I know that it should have an intercept at 2, 0. All right, so at negative a half 0, at 0, negative 2, and then a vertex at 3/4 and negative 25 over 8. And because this is actually symmetric, I know that there's another point right here, and the graph looks like this. All right, I'll try to be somewhat as accurate as I can be, but you can see that the vertex is going to be 3/4 negative 25 over 8. So let's draw these transformations. All right, so we have our parabola with the standard points at, again, the 0, 0, negative 1, 1, and 1, 1. And then if you move 3/4 to the right, so 3/4 to the right, and that looks by the way, this probably seems kind of in a way slightly strange, but just know that it's not as strange as it could be. All right, so just oh no, my graphing is not the best, but I think that most of you would hopefully realize that shifting 3/4 is not shifting this very far. So keep that in mind as well. And then I have a vertical stretch of 2. So if I stretch these by 2, these all get multiplied by 2 here. So So I just sort of want to make sure that this is going up an appropriate length and doubling. But I think that In my opinion here, and this is just my opinion. I mean, it's up to you if you really believe me or not. But that this is sort of a thing where this is a little bit distracting because of all these fractions here. But you can see that this is exactly what's going on, and then you're going to have a vertical shift to complete this translation, and this will be down 25 over 8. And I made this a little bit longer here so that you could see that this is sort of the shape that got shifted down a little bit, right? Because that looks a little bit wider. This is definitely narrower, and then that is something that's narrower than this that was shifted downward. All right, there you go. So what is the domain and range? Well, the domain, this is a polynomial, so negative infinity to infinity. And the range, the lowest y value is negative 25 over 8, so negative 25 over 8 to infinity. This is a parabola opening upward, so this is a function that is increasing everywhere, or on the interval negative infinity to infinity. And then this is a parabola that's opening up, so it does not have a maximum value, but the minimum value is y is negative 25 over 8 at 3 over 4. So the minimum value is negative 25 over 8, and this is the x value at which the minimum occurs. All right, let's try doing the same example using option 2 here. So determine whether the parabola opens up or down. So we have a x squared plus b x plus c. Since a equals 2 is greater than 0, this opens up. And then we'll determine the vertex. The x will be negative b over 2a. So that will be negative, now a, remember, is 2, b is negative 3, c is negative 2. So negative 3 over 2 times 2, so this will be 3 over 4. And then the y value will be f of negative b over 2a, or f of 3/4. So it's 2 times 3/4 squared minus 3 times 3/4 minus 2. So it's 2 times 9/16 minus 9/4 minus 2. So that's 9/8 minus 9/4 minus 2. So if I find a common denominator, it's 9/8 minus 2 over 2, 18 over 8, and 8 over 8 minus 16 over 8, and that's negative 25 over 8. So you still get 3/4, and negative 25 over 8 is the vertex. The axis of symmetry is negative b over 2a, which is the x value of the vertex, 3 over 4. Determine the y-intercept. The y-intercept will be the f of 0, so that's 2 times 0 squared minus 3 times 0 minus 2, so that's negative 2. So you still get a y-intercept of 0, negative 2. The x-intercepts, because we did not complete the square, you have to have 2x squared minus 3x minus 2 set equal to 0. You can either factor this or use the quadratic formula. So if you factor, you have 2x and x. All right, so it should be minus 2 plus 1 equals 0. So 2x plus 1 is 0. Subtract 1 to get 2x equals negative 1. Divide by 2 to get x is negative 1/2. and x minus 2 is 0. Add the 2 to get x equals 2, and you still get the x-intercepts are negative 1 half 0 and 2, 0. All right, so determine an additional point by using the y-intercept and the axis of symmetry. So what does that mean here? The y-intercept is 0 and negative 2, and the axis of symmetry is actually, here it is, 3/4. So if this is 3/4, and I add another 3/4 to this, and then I get 6/4. So this is, let's see, where was I? This was 0, negative 2, and that's 3/4, and so this will be 6/4 negative 2, or 3/2 negative 2. So that's another point that is on the graph. And now all I need to do is plot all these points. So why don't I list them over here? I had the vertex, which is 3/4 negative 25 over 8. I had the intercepts, which were 0, negative 2, negative 1 half 0, 2, 0. And I had an additional point, and that was 3/2 negative 2. And now I can graph this parabola here. So 0, negative 2, negative 1/2 0, 2, 0, 3/4 negative 25 over 8. And there's my additional point. And, well, guess what? I did this all without completing the square, and I got the same result. All right, so keep that in mind, that this is another option, and your domain is still going to be negative infinity to infinity. Your range is still negative 25 over 8 to infinity, and this is still increasing everywhere or on negative infinity to infinity, and the minimum value is still y equals negative 25 over 8 at x equals 3 over 4. All right, what a time to be alive. Now, let's do example 4 here. So use the given information to find an equation of the parabola with vertex at 2, 5 that passes through 3, 2, expressed in the form f of x equals a times x minus h squared plus k that satisfies the given condition. So we know that the vertex 2, 5 is hk, and then we know that it passes through the point 3, 2. All right, so we know that this is a point x, y. So f of x is a times x minus h squared plus k, or y equals a times x minus h squared plus k. We have everything that we need to find a now. So y is 2, a we don't know, x was 3, h was 2, and k was 5. So 3 minus 2 squared is 1, so 2 equals a plus 5, subtract 5, and a is negative 3. So the equation is f of x is a, negative 3, times x minus h, which is 2, squared, plus k, which is 5. There we go. What a time to be alive. Let's try an example here. Without graphing, find the extreme value of f of x is 3x squared minus 24x plus 53. Well, a is 3, b is negative 24, and c is 5. And remember, the extreme value is negative, is the vertex, by the way. All right, it's negative b over 2a, f of negative b over 2a, and it is a minimum since a is greater than 0 and the parabola opens upward. So it's a minimum since a is greater than 0. So the x value here is negative 24 over 2 times 3. So that's 24 over 6, which is 4. And then the y value is f of 4. So that will be 3 times 4 squared minus 24 times 4 plus 53. So that 3 times 16 minus, what is that going to be? 96 plus 53. Then 3 times 16 is 48 minus 96 plus 53. All right, 48 minus 96 is negative 48 plus 53. And negative 48 plus 53 is 5. So this ends up being 4, 5. What a time to be alive. All right, so I don't think that you would necessarily expect this to be 4 or 5, but it is. It's something that did not turn out as bad as it may have seemed, given that this was 53 right here. All right, so sketch the graph of x equals negative 2 times y plus 1 squared minus 5. Indicate the vertex in the x-axis of symmetry. And does the graph represent a function? Well, remember that this is x equals and not y equals. So let's go ahead and make a table here. So if y is negative 1, then x will be negative 5. All right, so here we go here. So 1, I'll just graph it. Negative 5, negative 1. All right. If you didn't believe me here, if I have x is negative 2, y plus 1 squared minus 5, but y is negative 1, I have negative 1 plus 1 squared plus 5. That's negative 2 times 0 squared plus 5. And that should be, I put plus, but there it was minus. I knew it. What a time to be alive. All right. All right, minus 5. And so that will be 0 minus 5, negative 5. So if you didn't believe me, that's how I got the negative 5 so quickly. Now, let's say y was, say, 0. So x is negative 2 times 0 plus 1 squared minus 5. That's negative 2 times 1 minus 5. That's negative 7. All right, so 0, negative 7. So negative 7 and 0, it's right here. Now, why don't I try a y is negative 2. So negative 2 times negative 2 plus 1 squared minus 5. And I have negative 2 times 1 squared, or negative 1 squared, but if I square that, it's still 1 squared. So that's negative 2 minus 5, negative 7. So negative 7, negative 2. And I know this is a quadratic, but because it is an x equals, it's actually going to open left or right, and so this one actually opens to the left. And then I see that this is the vertex here at, where is it, negative 5, negative 1, and the x-axis of symmetry here then is y equals negative 1, so axis of symmetry, y equals negative 1, and it is not a function because it does not pass the vertical line test. There are other ways you could figure this out, but that is one of the ways that you could tell that this would not be a function. All right, so unfortunately, that is all the examples I have for you in this section on this topic of quadratic functions and models. I really hope that you enjoyed this video and that you are already looking forward to the next one. What a time to be alive. Thank you and have a great day.